Dear students, welcome to the lecture on perspective projection. This is one of the topic in the fifth module of the course Engineering Graphics. This lecture covers the concept of perspective projection. Then we will compare this projection with the orthographic projection. Then the basic elements of perspective projection and the different methods to draw the perspective projection, and finally we will discuss some problems. What is perspective? To get the concept, let's take a look at these pictures. First one is a real life photograph, and second is a famous painting by Da Vinci created years back. Can you see something strange here? If you observe closely, we can see that both figures are converging to a point, isn't it? Let's observe the first one. We know that these tracks are parallel in reality, but if we draw lines through these tracks, it will converge to a point. See the lines drawn through these railway tracks, and also the lines drawn through the ends of the sleepers here. All these lines are converging to a single point somewhere here. I can also draw the lines through these sides. That will also meet the same point. Now just concentrate on the sleepers connecting the rails. The sleeper closer to you appears larger in size, and if we move farther, its size reduces continuously. Let's see the painting now. If we draw the lines through the corners of the room and also through these edges, all these lines converging to the forehead of the Christ. Da Vinci actually uses the concept of perspective projection to look the painting more realistic. Just take some more examples, real life examples. In all these pictures, real parallel edges appears to be converging to a single point. This is actually the concept of perspective projection. So from all the above examples, we can conclude that the perspective projection gives the most realistic view of an object, and it is the pictorial view of an object as seen by the human eye. It shows an object as it appears instead of showing its true shape and size. Now let me compare the perspective projection with the orthographic projection. Actually, orthographic projections are two types. One is multi-view projection and the other is isometric projection. In multi-view projection, to get the projections, we should have at least two plane of projections, horizontal plane and vertical plane. So here we have an object. The important thing is the observer is placed or standing at infinite distance from the object. And we have a plane of projection, and if we draw the projectors through the corners of the object, we will get the object on the projection plane. So these are the points to be noted here. The observer is at infinite distance from the object in case of orthographic projection. The projectors or the lines of sight are parallel to each other and perpendicular to the plane of projection. In case of isometric projection also, the projectors are parallel to each other and perpendicular to the plane of projection. The observer is standing at infinite distance from the object. So in both these projections, the relative position of observer, object and the plane of projection are insignificant. But in case of perspective projection, the relative position of observer, object and the plane of projection are very important. Let's see, we have an object here and this is your projection plane and the observer is standing somewhere here. The visual rays or line of sight are passing from the observer's eye or station point, which is also called station point, towards each corner of the object. So the important points here is the observer is not at infinite distance. The observer is at finite distance from the object. The lines of sight converge. The lines of sight converge at the observer's eye or station point here. So, and if the object is on the projection plane, you will get the true size of the object. If the object is behind, as you can see from the picture, you will get a reduced size in the perspective projection. So obviously, if the object is in front of the picture plane, you will get a larger size in the perspective projection. To draw the perspective projection, we should know the various elements first. These are the basic elements involved in the perspective projection. Let me explain one by one. The ground plane. The ground plane is a horizontal plane on which the object and the observer is assumed to be located. It is denoted with GP. The second one is picture plane. It is a vertical plane, vertical transparent plane where the perspective view is formed. It is denoted with the PP. So the PP is always perpendicular to the ground plane, GP. Next one is auxiliary ground plane. It is denoted with the letters AGP. It is a horizontal plane parallel to the ground plane. Sometimes it may be given that the object is placed on AGP, which is at a height from GP. And next element is station point, which is denoted with the letter SP. This is a point where the eye of the observer is located. It is always above the ground plane and also always in front of the picture plane. The next plane is the horizon plane. It is actually an AGP, an auxiliary ground plane parallel to the ground plane, which is passing through the station point. This is used to locate the station point in front view. Then the last one is central plane. It is a vertical plane perpendicular to both PP and GP and passing through the station point. The central plane is used to locate the station point with respect to the object. There are some more terms to be discussed. First one is ground line. Ground line. The ground line is the line of intersection of the picture plane and the ground plane. See, this line is the ground line. So ground plane is coinciding the ground line in the front view. The second one is horizon line. It's denoted with the HL. This is the line of intersection of the horizon plane and the picture plane. The front view of the station point is always located in the horizon line. Always located in the horizon line. Front view of the station point. And next term is axis of vision. It is a line drawn through the station point and is perpendicular to the picture plane. A line drawn through the station point and is perpendicular to the picture plane. The other term is center of vision. It is a point where the axis of vision is pierces the picture plane. Okay, the entire element shown here is actually a 3D system. As we all know, the perspective projection is a pictorial representation of a 3D object into a 2D plane. We need to convert this system into a 2D system. For that, we need to draw the front view and top view of all the elements by using orthographic projection. Here, the basic difference is what we have studied in the orthographic projection. We are not using any quadrant system here. Simply draw the front view and top view of the system by considering the observer is at infinity. In front view, this is the front view direction. You can see the ground plane, the horizon plane, the station point, and also the object which may be placed above the ground plane, on the ground plane or some distance above the ground plane. The ground plane appears as a line in front view, which is the bottommost line in our system, in our 2D system. Also, the horizon plane is also appears as a line. So, ground plane is represented with GL, ground line, and the horizon plane is represented with HL. So, the horizon line is always at a height which is equal to the observer's height from the ground plane. You will get the elevation of the object or the front view of the object here, which is always above the ground line. Now draw the top views. This is the top view direction. In top view, the picture plane, this is your picture plane, this picture plane appears as a line which we can denote it with the line PP. Okay, then this PP line you can draw with a convenient distance from the horizon line. And in top view again we can see the plan of the object or top view of the object. The object may be placed behind PP. If it is behind PP, the plan of the object is above the PP line, or if the object is placed in front of PP, it will be, the plan of the object will be below the PP line. Sometimes the object may be crossing the picture plane, so at that time your plan will be crossing the picture plane PP line. We also need to locate front view and top view of the station point, because here the observer is at a finite distance from the object. To locate it, we need three distances. The distance of the observer above the ground plane is this distance. It is the level of the horizon line. The second, the distance of the observer in front of PP, that is this distance from the PP line. And finally, the distance of the observer from the object. The observer may be towards the left of the object, towards the right of the object, or right in front of the object. We know the central plane. This is your central plane. We know the central plane is passing through the station point. So, to locate the distance of the station point from the object, draw the central line first. If the observer is located towards the left side of the object, then the central line will be on this side. Okay, so the central plane CP appears in front view and also in top view as a line. So it is denoted with the ZL, central line. Now, to locate the top view of the station point, just mark the distance of the observer from the PP line. the distance of the observer in front of the PP. And to locate the station point's front view, this is the point, because the horizon plane is passing through the station point. So the meeting point of central line and horizon line will give you the station point's front view. If the observer is right side of the object, then you can find the station point's top view here and the station point's front view here. If it is right in front of the object, then you can draw the central line here, and also to find you will get the station point's top view here. And till now we have discussed the concept of perspective projection, the various elements or terminologies we are using in this type of projection, and also how we will convert the 3D system into the 2D one. So here are some important points to be remembered. First one is the horizon plane HP referred with the ground plane, and it is always above the ground plane. The height of the observer equals the height of the horizon plane from the ground plane. So the front view of the station point SP dash is on the horizon line. The distance of the observer from the picture plane represented as top view of the station point. The top view of the station point is always below the picture plane. So always the observer is in front of PP. So it will be below the PP line. The central plane referred with respect to some point on the object. Always the central plane is referred with the object, some points on the object. Front view and top view of the station point lies on the central line. There are basically two methods to draw perspective projection: the visual ray method and the vanishing point method. Here we are going to discuss the visual ray method only, because you can solve any type of problem with visual ray method. Let me explain the visual ray method by solving a simple problem. A straight line capital AB 50 mm long lies on the ground and is inclined 30 degree to PP, picture plane. The end A of the line AB is 25 mm behind PP. The station point is 50 mm in front of PP, 60 mm above the ground plane, and lies in a central plane which is 80 mm to the right of the point A. Draw the perspective view of the line AB by visual ray method. This is our problem. Let me go to the so these are the given data. To solve this problem, first draw the front view and top view of the entire system using the method of orthographic projection. The first thing you can draw is the ground line, because in the front view this ground plane appears as a line. So you can draw this ground line at the bottom portion of your paper. Then it is given that the station point is 60 mm above the ground plane. So we all know the station point lies on the horizon plane. So you can draw the horizon line that is a front view of horizon plane, which is at 60 mm above the ground line. Next, you can draw the top view. In top view, the picture plane appears as a line, that is the PP line. Okay, so this PP line you should draw at a convenient distance from the horizon line. That convenient distance should be more than that of this distance, 50 mm, because the station point is 50 mm in front of PP. It is given in the problem. So this distance between HL and PP line should be more than that of 50 mm. Now you can draw the top view of the line. So it is given that the line is inclined 30 degree to PP, and one point A is 25 mm above the PP line. So draw a line which is 25 mm above PP, then you mark a point there, that is point A, then draw your true length of the line, that is it is given that AB is 50 mm. Because the line is lying on the ground plane, you can see the true length in top view. Okay, so with the 30 degree incline to PP, you can draw AB, which is 50 mm in length. Okay, so this is your top view of the object or line. Here it is a line AB. Now you can draw the corresponding front view, which is lying on the ground line, because it is lying on the line is on the ground plane. So your front view is on the ground line, A dash, B dash. Now the next step to follow is to find the station points. Find the station points in front view and top view. So we all know the station point. You should to locate the station point, we should have two dimensions in top view and also two distances in front view. Okay, in top view you should find the distances from PP, that is in front of PP, and also the distance from the object. It is given that the central plane, or central plane means the station point is the vertical plane passing through the station point. So the station points front view and top view is lying on the central plane. So central plane appears as a line in top view and also in front view, because that plane is perpendicular to both picture plane and ground plane. So that line you can draw from the point A towards 80 mm to the right. Okay, because it is given that the central plane is 80 mm to the right of the point A. Okay, so mark central line here. Now you can draw the top view of the station point, which is 50 mm in front of PP. So you can draw it is 50 mm below the PP line, and of course you have already marked the height of the observer here, that is the horizon line. So the intercept between horizon line and central line will give you the station points front view. Now, to complete the problem, to find the perspective view of the points A and B, this is the procedure to follow. First, you draw the front view visual rays. Front view visual rays. These are the front view visual rays. The line connecting station points front view and the front view points of the object. So SP dash A dash is the front view one of the front view visual ray. SP dash B dash is the another front view visual ray. Now you can, to find the perspective point of A, you draw the top view visual ray from SP to A, and you will get a intercept of this line with the PP here. From this point, you draw a vertical projector line towards the corresponding visual ray in the front view, that is SP dash to A dash. You will get capital A. This capital A, you should denote the perspective view of the point with capital letters. So this is your perspective view of the point A. And to find the perspective point of perspective view of point B, you draw visual ray, top view visual ray from SP to B. Then from the intercept on PP, draw a perpendicular projector line towards the corresponding visual ray in front view, that is SP dash B dash. You will get capital B. Now we join A and B, this line to the perspective view of the line AB. Okay, so this is a problem. Here you should draw all the lines except this perspective view edges, all the lines with light lines. You can draw PP line, HL line and GL line, also CL line with dark line, and rest of all the lines, dimension lines, visual ray lines, the front view and top view of the object, dimensions, everything should be light, and only the perspective view should be with the dark line. So the previous problem we have done with the visual ray method. Basically, these are the steps to follow in visual ray method. Let me explain. The first step is draw the ground line at the bottom portion of your paper. Then draw the horizon line. Always the horizon line, the distance between the ground line and the horizon line will be the height of the observer. So the front view of the station point is always on the horizon line. So the next step is draw the top view of the picture plane, that is called PP line. The height of the PP line above the horizon line should be more than the distance of the observer from the picture plane. Always the distance of the observer is below the picture plane. So the distance between horizon line and PP line should be at a convenient distance, but it should be more than the distance from the PP line to the observer. Okay. Next step, draw the front view and top view of the object based on the position with respect to PP and GP. The object's position with respect to PP and GP. Then locate the position of the central plane with respect to the object and represent it as a perpendicular line with both PP and ground line, PP line and ground line. Okay, then on the central line, mark the top view of the station point and the front view of the station point, which is denoted with the SP and SP dash, sometimes simply S and S dash, okay, of the station point based on its position with respect to PP and GP, picture plane and the ground plane. Distance of SP dash measured from ground line upward, because always the observer is above the ground plane. Anyway, distance of SP measured from PP line downward always, because the observer is always located in front of PP. So SP is always below the PP line. Now draw visual rays from SP dash to all elevation points of the object. Then draw the visual rays from SP to all plan points of the object, all the top view points of the object, and note the intercepts of each top view visual ray with PP line. From each intercept with PP, draw projectors vertically to meet the respective front view of the visual ray. These points are named with the capital letters A, B, C, D, etc. Then join all these points, you will get the perspective view of the object. These are the basic steps to follow in the visual ray method. Okay, let's take another example. A regular triangular prism. Regular triangular prism means all the base edges have same length. A 40 mm side of base and axis 80 mm long lies on its rectangular face on the ground. A triangular base is parallel to and 15 mm behind PP. The observer is viewing the object from the point 50 mm above the ground plane and 30 mm in front of PP. This is central plane is 90 mm towards the left of the axis of the prism. Draw the perspective view of the prism. Before solving this problem, let me explain some tips to find the hidden or visible edges in the perspective view. Actually, in the previous problem, we just considered a simple line. But here, it is a prism which is having more edges. Some of the edges may be hidden and some may be visible. So, it is important to discuss how to find the hidden or visible edges. So, the tip number 1 is boundary lines of the perspective projection are always visible. All the boundary lines of a perspective projection, perspective view are always visible. That is the rule number 1 or tip number 1. After doing this rule number 1, after drawing all the boundary lines with visible edges, then view the top view and front view of the object from the corresponding views of station points. That is, from the top view of the station point, view the top view of the object, and from the front view of the station point, you view the front view of the object. So the edge or a corner within the boundary, the edge or a corner within the boundary in the perspective view nearer to the station point nearer to the station point, both front view and top view will be visible and vice versa. In other way, you can say the edge or corner within the boundary of the perspective view farther to the station point in front view and top view will be invisible in the perspective view. Okay. The next tip is a line crossing a visible line in the perspective view will be invisible and vice versa. In other way, you can say a line crossing an invisible line in the perspective view will be a visible line. Last tip is all the lines joining a point within the boundary of the perspective view will be either visible or invisible. If you identify a point within the boundary is invisible, then there will be three lines joining to the base corner. Okay, so if you identify a base corner within the boundary is invisible, then all the three edges joining that corner, that point will be invisible. Okay, so these are the some tips to find the hidden or visible edges in the perspective view. Now let's discuss the problem. These are the given data. The size of the triangular prism is 40 by 80, that is 40 mm base edge and 80 mm height. And the triangular prism is resting on one of its rectangular face on the ground plane, with one triangular base is parallel and 15 mm behind PP. Because the triangular base is parallel to PP, its axis is perpendicular to the picture plane. So you can see the true shape of the base, triangular base in front view. That is your characteristic view. With that view only you can start the drawing. Okay. Then they have given the three datas to locate the station point's front view and top view. That are the distances of the observer from PP and GP, also from the object, that is central line. Central line is 90 mm to the left of the axis of the prism. In the previous problem, your station points are to the right of the object, but in this problem the station points will be on the left side. Okay, so let's begin with the ground line, and you draw this ground line at the bottom portion of your paper. Then draw your horizon line. It is given that the observer is at a height of 50 mm above the ground plane. So you can draw the horizon line at 50 mm above the ground line. On this line you will get the station point's front view. Now here you can directly draw the front view of the prism, because in the front view I have already explained that point, because the prism is lying on its face on the ground plane and its axis is perpendicular to the picture plane. You can directly see the true shape of the base in front view. So because it is lying on the ground plane, one edge, one face, rectangular face, you should draw on ground line, that is A, B, 2, 1. That is your rectangular rectangular base. rectangular face. Now draw the picture plane. The distance between the picture plane and the horizon line, PP line, and the horizon line should be more than that of the distance 30 mm. It is given in the question. The observer is 30 mm in front of PP. Okay, so this distance should be more than that of 30 mm. Then you can draw the top view of the object, top view of the triangular prism. Here by drawing perpendicular projectors from A, B, C. Okay, so I have taken the triangular base A, B, C in the front side, and 1, 2, 3 in the back side. Okay, and one triangular base is parallel to PP, so you can draw this line parallel with PP line, and this base is 15 mm behind PP. It is given behind PP, so we can draw this line 15 mm above the PP. Okay, and the height of the prism is given as 80 mm, so you can complete the top view of the prism. Now we need to find this or locate the station points front view and top view. For that, first you mark the center line. Okay, just given the center line is 90 mm, center plane is 90 mm to the left of the axis of the prism. So this is your axis of the prism, so you can draw the center line which is 90 mm to the left of the axis, that is this point. Okay, now on this center line you can mark the station points front view and top view. Station points top view is 30 mm below the picture plane, that is this point, and the meeting point of HL and CL will give you the station points front view. Now in visual ray, draw the visual rays, front view visual rays and top view visual rays, and then find the perspective points. Okay, then draw the visual rays in front view first, or we have 3 visual rays here, not 3, actually it is 6 visual rays, because this is 2 points, okay, A and 1. So this visual ray represents 2 visual rays. Okay, then to find the perspective view of point A, draw the top view visual ray from S to A, and from the intercept on PP, draw a perpendicular line towards the corresponding visual ray in front view, that is S dash A dash. You will get A. Okay, then follow these steps to find other visual rays or other perspective points. Okay, you can find B, C, 1, 2 and 3. Okay, now we consider the rules to find the visible edges and invisible edges. Here the first rule is draw all the boundary lines of the perspective points with the respective view with the visible lines. Okay, all the boundary lines of the perspective view is visible. Okay, so you can mark these are the boundary points, so you can draw these lines with visible edges, dark visible line, dark solid line. You can use dark solid line to represent a visible edge. Okay, so A, B, B, C, C3, 3, 1 and 1A. These are the visible edges here, or boundary edges here. Now we have we need to draw 1, 2, 3 and 4 edges is remaining here. Okay, so let's find the visible edge and invisible edge here. Here you can see to find the visible edge and invisible edge, the second rule is view the object from the station points top view and station points front view. Okay, the line or edge which is nearer to the station point in top view and also in front view will be visible. So in this problem, AC is an edge which is nearer to the station points top view, and in front view also AC is nearer to S dash. Okay, so we can say AC is visible. So mark AC with visible edge, visible line. Okay, dark solid line. Now let's check any edge which is crossing this visible edge within the boundary. This line is within the boundary. So if a line crossing a visible edge will be invisible. You can find an edge 2B. 2B is an edge which is crossing a visible edge AC. So that will be invisible. So dotted line, dark dotted line. So the last rule is if a point or a point within the boundary is invisible, then all the lines joining that point will be invisible. Okay, if a point within the boundary if all the lines joining a point within the boundary will be either visible or invisible. Here this line is invisible, so the point 2 is invisible, so the other two edges 2, 3 and 1, 2 will be invisible. Okay. With this problem is solved. Okay. In the previous problem we considered a prism and all of the prism was behind PP. Now consider a pyramid and one edge of the pyramid is on PP. Let me read the question first. A square pyramid, 50 mm base edge and axis 60 mm, rest on the base with one base edge on the picture plane. The apex of the pyramid is 50 mm to the left of the center plane. This sentence is a tricky sentence. Just remember. The station point is 50 mm in front of the picture plane and the horizon level is 30 mm above the ground. That means if it is given the horizon level is 30 mm above the ground, that means the observer's height from the ground plane is 30 mm. Draw the perspective projection of the pyramid. Okay, these are the given data in this problem. See, the size of the pyramid is 50 by 60, that is 50 mm base edge and 60 mm height, and it is lying on the base on GP with the one base edge is on PP. That means you can see the true shape of the base is in top view, not in front view like previous problem. So here you should start with top view first. Okay, so let's start with the ground line, then draw the horizon line which is 30 mm above the ground line. It is given that the horizon level is 30 mm above the ground plane. Now draw the PP line the distance between the PP line and the horizon line should be more than that of 50 mm, because it is given that SP is, the station point is 50 mm below the PP line, or the station point is 50 mm in front of PP. So this distance should be more than that of 50 mm. Now draw the top view of the pyramid first. It is given that the size of the base edge is 50 mm and it is resting on the base on HP with the one base edge is on EP. So draw one base edge on PP, that is AB, and then complete the base of the pyramid. Okay, so this is your pyramid, it's top view. Now you can draw the front view of the pyramid by drawing perpendicular projectors from each top view points. Okay, because it is resting on its base on GP, the base points, all the base points front view is on the ground line. Okay, A dash, B dash, C dash and D dash. You know, its height is given as 60 mm, so at 60 mm height you can mark right below the top view point O, you can mark O dash. Next you find the center line. In this problem they are given the axis of the pyramid is 50 mm to the left of the central plane. Axis of the pyramid is 50 mm to the left of the central plane. That means the central plane is 50 mm to the right of the axis, because we have drawn the top view and front view of the object first. Then you should mark the center line to the right of the axis. This is the axis point, axis in top view, this is a point. Okay, and this line, if you draw a line from O dash to the ground line, perpendicular line, you will get the axis line. So axis, from the axis 50 mm to the right, you can draw the center line. Now find the station points top view and front view with the given distances. Okay, already we have drawn horizon line, so the meeting point of horizon line and center line will give you the station points front view, and it is given that station point is 50 mm in front of PP, so you can mark that 50 mm below the PP line, you will get the station points. Here one next point is we have to draw the visual rays front view and top view and find the intercepts on PP and draw the perpendiculars. You will get the perspective points. Here you can see 2 points A and B. Point A and B is on PP. So here the top view visual ray intersect on PP at the same point here. So if you draw a perpendicular line from A, this point, towards its front view visual ray, that is SP dash A dash, you will get the same front view point here. So no need to draw the visual rays in front view and top view towards the points A and B, because you can directly mark that perspective point here. The perspective view of the points A and B is its front view itself. So this point is, you have point A and point B. Okay, this is your points. So now I need to draw the visual rays from SP to A and SP to B. Okay, to find other points, follow the procedure we have already discussed. Okay, find C, D, then you can find the point O, then C. After finding all the perspective points, apply the first rule, that is draw the boundary lines first, okay, with the dark visible line. So here in this problem, these are the boundary lines BA, AD, DO and OB, and then find a point which is far away or which is nearer to the station points front view and top view. In this problem, you can see the edge AO is nearer to SP, or you can, okay, AO in front view also AO is nearer to SP dash. So AO you can directly see okay. So AO is visible here, so mark AO first, then find an edge which is crossing this visible edge AO, that is CD. So that CD will be invisible because it is crossing a visible line. So if a point which is invisible within the boundary, all the lines joining a point within the boundary will be invisible. So the lines CO and CB will be invisible. Here one important point you can remember, that if a point or an edge is on PP, the perspective view of that point or edge will be the corresponding front view itself. That's why you got the perspective point of A and B same as A dash, the point A dash and B dash. Let's take another example. It's a cube of size 40 mm standing on standing on the ground plane with its axis on the picture plane. The station point is 50 mm above the ground plane, 30 mm to the right of the axis and 80 mm in front of PP. So the speciality of this problem is that the object is not fully behind PP. Some part of the cube is in front of PP, because it is given that the axis of the cube is on PP. Axis of the cube is on PP. So some part of the cube will be in front of PP and some part will be behind. Okay, let's go to the solution. Okay, these are the given data. It's a cube of size 40 mm and it is resting on its base on GP with the axis is on the PP, and they have given the 3 dimensions to locate the station points. Okay, let's begin with the ground line. Okay, then draw at 50 mm above, draw horizon line because the observer is 50 mm above the ground plane. Now at a convenient distance we should be more than 80 mm in this problem. Okay, with the horizon line draw PP. Okay, the distance between horizontal line and PP line will be more than that of 80 mm. Okay, now in this problem you can draw either the front view of the cube or the top view of the cube. Let's start with the cube, top view. In this problem it is given that the axis of the cube is lying on the PP. Axis is on PP. So your top view will be like this. Some part of the top view of the cube will be below the PP line and some part will be the above PP line. Exactly half. Okay, because the axis is at the center of the square here. Okay, now you can draw the corresponding front view. Okay, here I have taken A, B, C, D as the bottom base and 1, 2, 3, 4 as the top base. Okay, A, B, C, D as the bottom base and 1, 2, 3, 4 as the top base. Okay, now in this problem we have 4 points right below the PP line. So to find these points, if we draw the station points, let's find the station points first. Okay, to draw the station points, to find the station points, first draw the center line which is 30 mm to the right of the axis of the cube. Okay, let's draw the center line, then mark station points top view on the center line which is 80 mm below the picture plane, and the meeting point of horizon line and the center line will give you the station points front view. Now to find the perspective view of these 4 points, you have to extend, you should extend the visual rays up to PP. That is our procedure in visual ray. Okay, so the top view visual ray should meet PP, because these points in front of PP normally it won't meet. Okay, so you should extend it up to PP. Let's see, you should extend it up to PP, then draw a perpendicular projector line from that intercept on PP. Now in front view also you should extend the visual rays up to this perpendicular projector line, then only you will get the perspective point of B. If you want to find the perspective point of B, draw the front view visual rays from SP dash to B dash and extend it up to this perpendicular projector line. You will get the point B. To get the point 2, extend, draw the front view visual ray and through 2 dash and extend it up to this projector line. You will get the point 2, perspective point 2. Like the other 2 points you can find using the same procedure. Okay, draw visual ray in top view from SP to A and extend it to PP line to get the intercept, then draw a perpendicular line, perpendicular projector line, then draw the corresponding front view visual ray from SP dash to A dash and extend it to the perpendicular projector line. You will get A, and also you can find the point 1. Okay, this is the speciality in this problem. Rest for the other 4 problems you can other 4 points you can find by follow the previous procedure. Okay, draw, visualize and find other 4 points. Okay, now after finding all the perspective points, apply the rules. The first rule is all the boundary lines of the perspective view will be always visible. So here in this problem, these are our boundary lines 4, 3, 2, B, A, D, 4. These are boundary lines. Let's join these boundary lines with a dark line. Okay, dark visible line. Now, after joining all these boundary lines, let's find an edge or a point which is nearer or far. Okay, if it is nearer, that will be visible. If that edge is far away from the station points front view and top view, you will get that edge will be invisible. So in this problem, you can find a visible edge A1, which is nearer to SP in top view, and also in front view you can see A1 dash and A dash is nearer to SP dash. So you can draw A1 as a visible line. If the edge A1 is visible, it means the point 1 is visible. So all the lines joining the point 1 will be visible, that is 4, 1 and 2, 1 will be visible. Let's check another rule. Let's check edge which is crossing this visible line within the boundary. So you can find 2 edges CD and C3 which are crossing these 2 visible lines, so we can say that edge will be invisible. Okay, a line crossing a visible line will be invisible within the boundary. So if this edge and this edge is invisible, that means the point C is invisible. So you can join the other edge CB with a dotted line. Okay, if this problem is solved, this is your perspective view of the cube. Okay, now the point should be remembered here is, if a point is in front of PB, the perspective view of that point will get by extending the visual ray in top view up to PP, like this. Okay, like this. Okay, then draw perpendicular projector to the corresponding extended visual ray in front view, like this. Okay, so this point should be remembered here. If some part of the object will be below PP, you have to extend the visual rays in front view and top view to get the corresponding perspective view of that point. Okay, one more thing you should remember, you should careful about drawing the ground line. Here, if some part is in front of PP, the perspective view, some part of the perspective view will go down to the ground line. So be careful, you should give some space at the bottom portion. Let's discuss the last problem in this session. A square pyramid, 40 mm edge of base and 40 mm axis height, is resting on its base on the ground with a base corner is on PP and an edge containing that corner is making 20 degree to PP. So the station point is 30 mm in front of PP. The horizon plane is 60 mm above the ground plane. The axis of the pyramid lies in the central plane. This is a new thing. That's why I highlighted here. Draw the perspective view of the pyramid. So these are the given datas. The size of the pyramid is 40 by 40, that is 40 mm base edge and 40 mm height. It is resting on its base on the ground plane with some angle with PP. Okay, so in top view you can see the true shape of the base because it is resting on GP. So we should start with the top view. Then they have given the station point is 30 mm below the PP line, that is station point, the observer is 30 mm in front of PP, 60 mm above the ground plane, and the axis is on the central plane. So it's a central line passing through the axis point. Okay, so let's begin with the ground line, then draw the horizon line. Horizon plane is 60 mm above the ground plane. Then draw the PP line. The PP line should be more above the horizon line. The distance between these two should be more than 30 mm in this problem. Okay, now let's draw the top view of the pyramid. In top view you can see the true shape of the base with the, it is given that one base corner is on PP, so I have mark a point here on PP. Then one base edge is inclined 20 degree to the PP line. Okay, so first draw this line by putting a point here with the 20 degree with the PP. Draw a AB line with the 40 mm size, then complete this base. Okay, mark O here at the center. Okay, so these are the slant edges, these are the base edges. Now draw the corresponding front view. Okay, in this problem we can see that this point C is invisible in front view direction. This is actually the front view direction. We are here, so this is the front view direction. So B, A and D are visible in front view direction, but C is invisible because BA is right in front of C. So in front view, the corresponding front view of CO edge will be dotted line. Okay, then the height of the pyramid is 40 mm. So complete the front view. Now you can draw the center line. Okay, it is given that the axis is on the central plane in this problem. So this is a new thing. In the previous problems the center line may be right of the object or left of the object, but in this problem the center line is on some points of the object. Okay, exactly the point O. Okay, O and O dash is on the center line. So now just mark the station points top view and front view. Station points top view is 30 mm in front of PP, so it will be 30 mm below the PP line. Okay, then mark the station points front view. There is a meeting point of horizon line and center line. Now like our previous problems, you can find the perspective view of the base points, all the base points A, B, C, D. Here the point A is on PP, so you can directly mark the perspective view of that point as A dash. Okay, so this is your point A. Okay, then mark all the other points front view visual rays. Okay, S dash, B dash, S dash, C dash, S dash, D dash. Then corresponding top view visual rays from S to B, S to C, S to D, and find the corresponding perspective points. Okay, now you got all the base points perspective view. Now we need to find the perspective point of O. Perspective point of O. In this problem, the visual ray connecting O in front view and also in top view, will be perpendicular to PP. So you have an intercept here, but you can't find the corresponding perspective point on the line S dash O dash. Okay, we don't know what is the location here. So to find the corresponding perspective point of O, you should transfer this O to a convenient distance towards right, or you can transfer this towards left also. Okay, to a convenience distance by drawing parallel line to PP. Okay, then mark that point as O1, say it is another location of point O. Okay, then in front view also you transfer that O dash to the same distance. Okay, mark it as O1 dash. Now you can find the perspective view of the new point O1 by following the normal procedure. We drawing visual rays in front view and top view, and draw perpendicular projector from the intercept at P. You will get O1. Okay, so this is the perspective point of the point O1. Okay, now this is the location. This is actually the location of the point O, from which is the okay. Then now you can to get the original perspective view of point O, transfer back this point to the original visual ray, that is S dash O dash. Okay, just draw a parallel line from O1 to this original visual ray S dash O dash. You will get the corresponding perspective view of the point O. Okay, so this is the procedure when we have a point which is lying on the central plane. Okay, now you got all this perspective points, perspective views. Now apply the rules. Okay, first draw all the boundary lines with the visible edges, then find a point which is visible or invisible, okay, by viewing from the station points front view and top view. Here you can see the line CD, the edge CD is far away from the station points top view, so this CD will be invisible. Okay, so you can draw that invisible line first. Then after drawing this invisible line, you can draw the edge AO which is crossing this invisible edge, so it will be visible. Okay, with this I hope all the concepts regarding the visual ray method I have explained. Okay, in this problem we have got another points to remember. That is, if a point is on the center line, to find its perspective view, these steps to follow. Okay, transfer that point to the right or left for a convenient distance by drawing parallel lines to PP in both front view and top view. That are these lines. In this problem, this is a point which is lying on the central plane, so transfer this towards right or left, okay, to a convenient distance by drawing parallel lines in both front view and top view. Then now find the perspective view of the new point by following the normal steps. Okay, what is the normal step? Draw visual rays in front view and top view, and then draw a perpendicular projector from the intercept at PP. Okay, you will get the corresponding perspective view of the transferred point, new point. Okay, now to get the original perspective point, you transfer back this perspective point to the original visual ray in front view, that is S dash O dash in this problem. Okay, so I have added some practice questions in the next slides. Please practice all the questions yourself at home. Stay safe. Thank you.